Hello everyone, here is measures of central tendency. And so measure of central tendency numerically describes the average or typical data value. And usually we use the word average. Here we have examples. And each one you can see that word average, the average. So the first one, the average miles per gallon. The next one, according to the US Census, the national average. So here again, average. The third one, here again we have the average household income. And finally here, again we have the average American woman. So we have all these. For all of these, we use the average. What that means, here on this part, we're going to work on finding average or mean. Determine the arithmetic mean of a variable. And what that is, so arithmetic mean of a variable is computed by adding. So we're going to add all the values of the variable in the data set, and then after that divide by number of observations that we have, so that is in denominator. Now in the first part, here we have population arithmetic mean. The next one is sample arithmetic mean. The differences here for population, when you have population, you're trying to find average, you're going to use mu, show you with that one. But when you're working on sample, the difference is instead of using mu for average, now we have x bar. So that is x bar. What the formula is, we exactly have same thing, but the only part was that you're gonna have on your problems you're gonna have, okay, this is the example for population and that is sample. When you saw that word, just make sure that for sample you choose x bar and for population mu. Here we have all these observations, x1 up to xn. So we have n observations total because that is xn. N observations, and that is from population. So population mean is adding all these observations on top divided by number of observations we have. So in total we have n observation, that is in denominator. Exactly same thing for sample mean. This is sample mean. And that one is population mean. Again, same thing here. These are our data of x1 up to xn are, and we have n observations. So this is in denominator because in total we have n observations, and on top we should add all these data. So adding all these data divided by number of observations, that is number of observations. Same thing for this part. Okay, one more thing to cover for each one. The point is that the population mean is a parameter, and the sample mean is a statistic. What parameter is numerical summary of a population. So parameter is numerical summary of a population. Just keep in mind that since this one population started with P, we have same thing here. So that is P. So P and that one also P. Population parameter. Now this part here is sample mean is statistic. So that one was parameter is numerical summary of the population. This part here is statistic is numerical summary of a sample. Okay, so we have these two for this part. Here again, exactly the same thing. And sample starting with S, and that is statistic. Again, we have S. So S for S, and here P for P. And here I said that N is number of observations, or we can say population size, or population size. And here number of observations or sample size. Later, I'm going to use these two instead, population size and sample size, as we want to show what the difference is. Next page, example number 1, find the population mean or sample mean. Here on this part, I'm not going to use calculator or anything else. Only using these two, adding all the data and divide by number of observations. Here we have sample, part A, and part B is population. Since that is sample, we have X bar is equal to, adding all these numbers is 83 plus 65 plus 91 plus 87 plus 84. Divide by sample size as 1, 2, 3, 4, 5. It's 410 divided by 5 is 82. So our sample mean is 82. Now for this part B is population. Since we have population, instead of X bar, now we have mu. Adding all these numbers on top. Divide by how many numbers we have is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's equal to 105 divided by 9 is equal to 15. And this one is population mean. Okay, number 2. Here on this board, they sold 55 ad slots for a total revenue of roughly $165.50, and that is a million. What was the mean price? So we don't need to follow that formula here because we already have what the total price is. So total revenue is 165.5. You only need to divide by total sold is 55 to find the answer. So 165.5 divided by 55. It's $3.01, and this is a million. So this has mean price per ad slot. Okay, next part is determine the median of a variable. So on this part, we're going to work on finding median. That is, median of a variable is the value that lies in the middle. So it's in the middle of the data when arranged in ascending order. So first we should reorder them. Use M for median. Here we have steps to find median. So first step is always arranging the data in ascending order. Determine the number of observations, so sample size or population size, number of observations. Step 3, determine observation in the middle of the data set, depending on how many numbers you have. If you have number of observations odd number, meaning that, for example, if you had 3 numbers, that is odd. To find median, so median is the data value exactly in the middle of the data set. And what is the position of that one is? So that lies in n plus 1 divided by 2 position. This is the position of your median. That is not the number that you're gonna get for median. We're gonna work on that part. We're gonna have examples. So the next one, if the number of observations even, then median is the mean of the two middle observations. So that is our mean. And here is what the place of what the position of our median is. So the position is mean of the observation that lie. So it lie in n divided by 2 position and n divided by 2 plus 1. Okay, I want to have example for each one. When it's odd, when our observation is odd, and when it's even. So first example for, okay, let's use A for that one and B for this one. I'm writing that part here. Example for part A. We should have number of observations as odd. For example, 1, 2, 3, 4, 5. First, finding what the median is. The median is the data value exactly in the middle. You can start from left and here right and eliminate each one. So from here, I have one here. From right, I have another one. Again from left, now from right. What's left here is in between. So that is our median. Now finding the position of that one. This is in third place. It's not because of I have this 3 here. This is third place. So this is first, second, third. We may have different numbers here. So What if we had 2, 5, 7, 8, 9? Then again, what we have in between, this is median. And again, that is in third place. So position is, how many numbers we have in total here? We have 5 observations, same thing on top. And we're going to use that one, n plus 1 divided by 2. N is 5 plus 1. So that is 3, which is third place. So for both of these median is, the position of our median is in third place. And now another example for part B, when we have, when n is even or number of observations is even. Example 1, 2, 3, 4. I'm using the easiest example I can have here to start. Okay, so again, same thing, starting from left and right. So I'm moving, okay, from this part I have 1. Now from right I have 4. Eliminating, and I don't want to eliminate this because I want to have something here in between. So what that means, we have these two in between. To find median is equal to, adding these two, 2 plus 3, then divide by 2. So 5 divided by 2. So our median is between these two numbers, and that is 2.5. What its position is, that this lies in, obviously you can see this is first place, second place, third place. So our median is between second and third place. So this position is, lies in, and divided by 2, and divided by 2 plus 1. So this is where our median located. So first, n divided by 2 is, our n is 1, 2, 3, 4. We have 4 numbers here. So this is second place. And n divided by 2 plus 1. 4 divided by 2 plus 1. So that is third place. What that means, our median is between these two. So between second and third place. Once again, second and third place doesn't mean that I have, since I have 2 and I have 3. You may have different example. You may have, for example, 3, 4, 5, 7. If you had that, our median is here on this part, between second and third place. So this is another example. This is example 2 for part B. Okay, I'll rewrite that one. For example, 2, 4, 5, 7. The median is 4 plus 5 divided by 2. That's 4.5. And position is between second and third place. The N is 1, 2, 3, 4. We have 4 numbers. See, we have exactly the same thing. Because we have same number of observations. Here is 4 numbers. Here also we have 4 numbers. So this one is second, and this is third. Our median lies between lies in second and third place, and that is here. Okay, next page, example number 3. The following data represent the travel times in minutes to work for all 7. We have sample size. Here is 7. 7 employees of a startup web development company. So we have these numbers. Determine the median of these data. Here it didn't say if it is a sample or population, because that doesn't matter. But since we have 7 for all 7, that part we have all 7. Maybe we have 7 employees in total. But here it doesn't matter because we're gonna work on median. We're not working on mean. Okay, finding median of this data. First step, step 1, reorder. Should be in descending order. We have the smallest one is 5. Then after that we have 18, 23, 23, 26, 36, and 43. Then let's see how many numbers we have here. 1, 2, 3, 4, 5, 6, 7. So we have 7 in total, and our median should be in between. So this is what we have in between, and that is median. So n was equal to 7, and that was odd number. Now let's see where that is located. Obviously this is 4th place. So 1st, 2nd, 3rd, 4th place. Since we have odd, we're going to use n plus 1 divided by 2. Number of observations, n is 7. So 7 plus 1 divided by 2. And this is 4th place. Okay, so the answer for that part, median is equal to 23. Part B, suppose that they hiring new employee. The travel time of new employee is 70 minutes. Determine median of the new data set. Here exactly we have same thing, but the only difference is we added this 70 minutes for new employee. Again, step 1, reorder all these because we want to find median, and that is our first step. We have same thing, 518, 23, 23, 26, 36, 43, and 70. Okay, so now finding what median is. Median is in between. So you have 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 on left, 3 on right. What's left in between? We have these two, 23 plus 26 divided by 2. That is median. So median is, so this one was position. We have 23 plus 26 divided by 2, so that is 24.5. This is our median. And what is the position of that one is between. So our median lies in this part here. It's between 23 and 26. So it's the places 1, 2, 3, 4, 4th and 5th place. Now here is position. Since we have even, so here n is 8, and that is even, lies in, and divided by 2, and divided by 2 plus 1. N is 8. This is 4th place. And here is 5th place. So it's between these two. Okay, so we got median for each one using this method without using calculator, without using StatCrunch. Now let's use these two. We have TI-83 or 84 plus. These are steps. We want to enter our data in L1 by pressing stat. So first step is use your TI-84 and press that one is stat. Okay, I want to show that one. So after pressing stat is on the second row of your calculator. So first you have second, mod, del, then we have alpha, then you have ace, theta, and all those, and then after that you have stat. So press stat. You're gonna see this page. After that, just make sure that you have this part here. So you should have edit, and the first one is edit, enter. Okay, now you have this part. Here we have L1, L2, all these. You only need one column because we only have one set of data. So I'm going to enter data from example number 3, part A, but not in order. Order doesn't matter because it will automatically reorder it. So first I'm entering 23. So type in 23 here. You're gonna type that number here, and then after pressing enter, that number will show here on this bar on top. I'll continue like that, entering 36, then we have 23, 18, 5, 26, 43. Okay, so I have this. Okay, I entered all these data. We have 4, 5, 6, 7. So n was 7 in part A, and that is odd. Now we want to find what median is. So after that, the next step is again press that. So again, we have this page. We have this one. Now instead of using this edit bar, now I want to use that one. So move using that arrow thing you have on calculator. So move to the right. We have this. So I'm not choosing that one. Instead, we're choosing that one, and you should have number 1 is worse that. Press enter. You're gonna see this. Here our list is L1 because we only have one column. And that is frequency, so it's how many times we have for each part. So our data is L1. Press enter, enter, again enter. We have all these, so this is sample mean. We don't need that one here. That is n equal to 7, which is odd. Scroll down. Okay, scroll down. Here you can find median. Median is 23. So we got exactly the same thing for part A, example number 3. The answer for median was 23. Okay, now I want to try same thing for same data set for using StatCrunch. So let's use StatCrunch. So type in StatCrunch and sign in using same username password that you have on Pearson. Now open this one, open StatCrunch. So I'm not entering our groups. I'm just using this open StatCrunch. Okay, then so let's say this one is our L1. We can change that one to have, you can choose anything. Let's use L1 because that is variable. And type in all these numbers that we got here. Our data are 5. Okay, I don't want to write these in order, so let's try it that way. We have 23, 36. This is example 3, part A. 23. Then after that, we have 36. Then it's 23, 18, 5, 26, and 43. So we have 3, 4, 5, 6, 7 in total. So this is our first step using StatCrunch. Enter all these in one column and name the column variable. So we choose to have L1. Then step 2, select stat. Here we have the summary stats. Then we have columns because here we have columns. That's why we're choosing that one. So columns. Selecting what columns we have. This is the only one I have. Then compute. Now we have all these NS7, mean. We're gonna work on that one. Yeah, example number 4. Example number 4, again, we have same data set. And I'm going to have same number that we got here is 24.571. If you run it, the answer will be 24.9. We don't need that one here, not that one. And median is 23. Okay, we're gonna cover these later. So for now, just focus on median as 23. And our mean, which is on example number 4, is 24.9 after rounding. Okay, so here is example number 4 that I said we have same data set. Suppose that a new employee is hired who has a 130-minute commute. On the spot, we added this new employee with having 70 minutes, but here on the spot, we have 130. So instead of that 70 that we had on part B from example number 3. Then how does this impact the value of mean and median? So here on top is mean before new hire and median before new hire. So first, we already have the answer for this part using StatCrunch, and I already know that after rounding, the answer for this part is 24.9. Or even if you didn't use the StatCrunch, that's fine. Just adding all these numbers for this part. Mean. We have 23. I'm adding all these numbers. Divided by number of observations is 7. Rounding it, the answer is 24.9. So that is our mean. Now, what median is? First step, writing these numbers in order. From example number 3, we know the answer is 23. I'm writing this again. So we have 7 numbers, and this is what we have in between. That is median. Okay, now finding mean after new hire. So adding 130, we're gonna have these set of data. Adding all those numbers. divided by 8. And that is equal to 38. I'm going to use the south current for this one. Okay, so that is 38. Now median. Writing all these numbers again, because these are in order. We have one more is 103. So our median is in between. So from left side 1, 2, 3. And here from right side 1, 2, 3. What's left in between? It's 23, 26. So our median is 23 plus 26 divided by 2. That is 24.5. The point is, mean is sensitive to extreme values, while the median is not. See what the difference is? This is huge difference between that number 24.9 and here we have 38. By only adding one number, one data here, adding that one, see, this increasing too much. So it's huge difference. But here for median we have 23, but that one is 24.5. It's not that much. Here is mean is sensitive to extreme values while median is not, because extreme values do not affect the value of the median. What that means, median is resistant. Okay. So we had this one for before new hire, and we added one more. So exactly we have same numbers, but adding 103 here. So again, stat, summary stat, columns. Choose that one. So you should have L1 here. Then compute. Now let's see what this one is. Mean we got 38, so we have same answer on this board. Median is 24.5, so we have same thing, exactly same thing. It is 24.5. Okay, so this is related to what we have here. Numerical summary of data is said to be resistant if extreme values very large or small relative to the data do not affect its value substantially. Just keep in mind that mean is sensitive to extreme values while median is resistant. Okay, here again we have symmetric, skewed left, skewed right. We had skewed left, skewed right, and yeah, we had these period section. So skewed left wise, left tail is longer than what we have on right. Then we have symmetric is bell-shaped. So mean is equal to median. And here is skewed right. What that is right tail is longer than what we have on left. When you have skewed left, that means mean is less than median. So this is our mean, is in between. So that is our average. So mean is less than median. But for symmetric, mean is exactly equal to median. And when it's skewed right, so this is average. Now mean is greater than median. So you only need to remember these. This one for skewed left, and this one for skewed right. And this is obviously equal to. Okay, example. For each of the three diagrams shown, determine whether the mean is greater than, less than, or approximately equal to median. Here is the highest frequency that we have here on this frequency. Here we have frequency, so this is the highest number that we have for frequency. So that is our peak, and this is right tail. So our right tail is longer than what we have on left here. So this is longer. Since we have that one longer, see, that part is here, this is skewed right. Since we have skewed right, our mean is greater than median. Now, what is this one? This is the highest frequency we have. And that is, we can say that is in between. What that means here is symmetric. That's why mean is approximately equal to median. Now here's the highest frequency that we have. And this left tail is longer than what we have on right. So this is longer. And we have skewed left. Since we have skewed left, mean is less than median. So this is enough for this part, but we can also show that with numbers where our median is located and what is our mean. So what that is exactly, and then you can see that this is obviously correct. Let's try one of these. You don't need to learn that one. I only want you to learn all these. But let's work on one of these. I want to work on the third one here. First, I'm going to write what is the frequency for each one. So this one here is 2. Here is 2.5. Then here is 6. This is 12.5. Here we have 14.5. And here's our frequency is 12.5, so the same as that one, 12.5. First step, finding sum of frequencies. Guys, we're gonna use that one to find median. So adding all these numbers, we have 2 plus 2.5. So this is equal to 50. And what is that one? This is number of observations. Now finding median. So number of observations, n is equal to 50, and that is even. So it's even. To find, this is median position, where that is located. It's n divided by 2. So n is 50 divided by 2. We have 25. And here is n divided by 2 plus 1. So that is 26. So our median lies in 25th and 26th place. Okay, now let's see what is our mean and then compare. For now, we only need that one. Using these, we can see where that mean and median is located, so we don't need to find what the median is for that part. Now mean. Number of observations denominator is 50. Now what we have on top, we're gonna use this histogram. Here is 0. 0 multiplied by, how many times we have this 0 is 2. So multiplied by 2 plus, now this is 5. How many times we have this 5 is 2.5. The next one is 10. How many times we have 10 is 6. Plus, after that 15 multiplied by 12.5. Then 20 multiplied by 14.5. 25 multiplied by 12.5. So this is 25 multiplied by 12.5. And that's it. So we used all these frequencies. Multiply and add. So this is 0. Oh, okay, it's 12.5 plus 60 plus 187.5 Here denominator is 50. $290, 312.5. So in total we have 862.5 divided by 50. So that is 17.25. Okay, so our mean is 17.25. Now let's see where our median is. Median is, adding all these, we have 2 plus 2.5 plus 6 plus 12.5 plus 14.5. We have 10.5. This is 23. So obviously 25th is here and also 26 is here. So here we have median. Our median is here, and our mean based on what we have here is, see, we have in between. Yeah, approximately is in between. So it should be somewhere here in between. And that is 17.25. Okay, so it should be there. Here is our mean. And mean is less than median. So mean is less than median. Next part. Determine mode of a variable. What that is, mode of a variable is the most frequent observation of the variable that occurs in the data set. Set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, so no observation more than once, we say the data have no mode. I'm adding this part. So mode is the number that is repeated more often than any other. Here example, the following data represent the asking price of homes for sale in Lincoln. So we have all these numbers. And these are in order. Yeah, so these are in order. This is minimum value. And here we have max. Find mean and median. Use the mean and median to identify the shape of distribution. Verify your result by trying a histogram of data. So first, what mean is, you need to add all these numbers, or you can use calculator. Stat, then exactly what I did on the example number 3. So press stat, then enter data in the first column L1. Again, use stat, choose calculate, and then choose the first one, which is var stat. So exactly these steps. So press stat, then choosing the first one, edit, enter your data here in the first column L1, and then again stat. Now choose calculate, and then the first part that we have is var stat. Press that one, enter. You're gonna have this one, L1, again enter. Then after that you'll be able to see your results. So do the same thing. I'm not going to have something like this on this. I don't want to have all these numbers like that. You may have like less than these numbers. So the answer for me, adding all these divided by total is how many observations we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 32. So mean is 168, 320. Now finding median, since n is, okay, I'm writing that part here, so n is 32, and that is even. So these numbers are in order. We have to start from here on top, then move down. Then after that we have this number. Again, moving down. So what's in between is this one and this one. Median is 147. 100 plus 149,900. Adding these two, divide by 2. And that's equal to 148,700. So this is median. And next one is mode. The point was that if no observation occurs more than once, we say there is no mode. Each one of these numbers, we only have 1 for each one. It's not repeating numbers here in this table. That means here is no mode. And what else? Here I want to write what classes we have. I'm going to use class width, class width of, let's see what we have here is 100,000. In between, this is 125,000. That is 150,000. So this is 175,000. Then 200,000. This is 225,000. That's why our class width is 25,000. So class width of 25,000 with a lower class limit of which is that one. This is 75,000. It's starting point, so it's lower class limit. With lower class limit of 75,000. Okay, so here I have frequency distribution. On this part we have our classes starting from 75,000. 75,000. Then here is 100,000, but we shouldn't write that one exactly here. So that 100,000 is our second lower limit. And this part is 99,999. Here is, so that one is, after this we have 125,000. Minus 1 is here, so 124,999. This is 149,999. $174,999. I'm subtracting 1 from this part to find that class. So here is 199,999. And that is up to, okay, here we have 325,000. This is 224,999. 249. And this one, 274,999. 299,999. Now finally this one is 349,999. So we stop here because this is the largest one is 350,000. So we stop there. And what is the frequency for each one? Based on what we have here, that is 2, 4, 11, 6, 2, 2. here is 0. When you're drawing this histogram, you don't need to write these data on top. I'm just writing to show that what we have for each part, what the frequency is. Okay, so I'm going to write all these numbers here for this part. And so we have 2, 4, 11. And also I didn't write that one, I only explained, so let's write that one too. I will not write numbers, I'm just writing what the formula is. So minus add all numbers in table divided by number of observations was, in total we had 32. Divide by 32. That is 168,320.125. Since it's in dollars, I'm gonna round to near cents, or rounding it. 168,320. So we got that number here. Okay, we finished this one. Next page, example number 7. Here we have this table that's given data represent the full carbon dioxide, and we have emissions in thousands of metric tons. That is for top 10 meters in 2007. So this data is for 2007. And in total we have 10 countries. So determine mean of the top 10 countries. So mean is equal to adding all these numbers. It's asking to find mean emissions. Here is this column is emissions. Adding all these numbers divided by how many observations we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we have 10 countries. Okay, adding these numbers on top, we have 5,362,367. So divide by 10, that is 536,236.5.7, and this one is 1,000 metric tons. Because we have this one. Okay, now part B explain why the total emissions of a country is likely not the best gauge of emissions, or instead emissions per capita, or total emissions divided by population size is a better gauge. Because per capita is better because it adjusts emissions for population. So after all, countries with more people will have higher emissions. So that's because related to what the population is. So it's dependent to population size. So per capita is better because it adjusts so these emissions depend on population size. That's why this is better choice. So countries with more people will have higher emissions. Part C determine the mean and median per capita emissions of the top 10 countries. Which measure with an environmentalist likely used to support the position that per capita emissions are too high. Why? Okay, so first finding mean, median. Okay, so on this part we have per capita emissions. We're gonna use these data. We have these. Adding all these numbers, here is 26.93. And divide by 10, so it's 2.693. And it's in 1,000 metric tons. So this is the answer for mean. Then after that, finding median. So we should write all these numbers in order because these are not in order, ascending order. Starting with 0.39. So the order. Then we have 1.35, 1.88, 2.41, 2.61, 2.71, 2.82, 2.95, 4.61, and 5.20. So in total we have 10. So 1, 2, 3, 4 from the side. 1, 2, 3, 4 from the side. What we have in between these two numbers. So median is 2.61 plus 2.71 divided by 2. It's 5.32 divided by 2. So this is again metric tons. Okay, so for me we got 2.693, but here for median is 2.66, and this is higher. So the environmentalist would use the mean because that is higher. So that is the support to, okay, which measure would he use to support a position that pre-calculated emissions are too high. Since we have that one too high, we're gonna use this one, which is higher. So he's gonna choose mean. So the environmentalist would use mean because it's higher. Okay, we finished this part. Thereafter, I'm going to cover next section.